Hi, everyone. My name is Aurora. I'm a web developer from Norway, and I work as a consultant at InMeta in Oslo. And I'm actively building with the Next.js app router in my current consultancy project. So I'm so excited to be here and be speaking about elevating speed, interactivity, and user experience with React Server Components. So with the release of React Server Components, the way we build apps has changed. Server components are components that only run on the server or in the build and never on the client. And this means that we cannot use our familiar state, effects, and browser APIs or hooks inside them. And this can feel very restricting at first. Server components, however, are extremely powerful, and they can do a lot of things. Excuse me. Yes, they can do a lot of things. For example, they can fetch data asynchronously and be async, and fetch data asynchronously right inside the component itself. Furthermore, since they're only run on the server, they can access backend resources directly and in proximity to the resource. For example, a database. And lastly, the JavaScript is never shipped to the client, which means that they reduce the bundle size and let us build more performant apps. Server components allow us to fetch and render on the server and then stream in the fully rendered components to the client as they complete while displaying a loading fallback with suspense. And this is beneficial because we are sharing the compute load between the server and the client, which is pretty incredible. But there are a lot of new development patterns to understand, especially related to handling data and creating good user experiences. And both Next.js and React have plenty of new tools to help us with this. Change and relearning is hard, but these new features unlock a lot of capabilities. So let's explore this by heading over to a demo. OK, let's see. OK, good. You can see the demo. So this is a project task manager demo application. And the designer of my current project, Eileen Rasholt, she's very talented. She designed the UI. And it's actually inspired by something we made in this project. And the setup here is, of course, the Next.js app router. I'm using Prisma as my ORM and an Azure SQL database, because it's free on my company account, and Tailwind for CSS. And let's begin by just looking at what we have here. Oh, that's blue. That's nice. Excuse me. OK, I don't know what that's blue. That's OK. So here we can see a project information, and we can navigate through these tabs. I was hoping you could see the URL here. I'm not sure. OK, there we go. Now it's not blue anymore. And we can also do a search, like CI/CD. Is it running? Yes. And this is now all server components, which means that there is no JS on the client for any of these components. And it's all just HTML and links and a form. And this is a good base case because it can run really well on a device that has a lower processing power because it does not need JavaScript to run. And let me also look at the Lighthouse score for this. By the way, I forgot to refresh this, but you'll notice it has a very slow initial load here. And that's because I slowed down the data fetches on purpose for the sake of the demo. And that's reflected in the Lighthouse score. So the first contentful paint and the largest contentful paint come in after 3.1 seconds. And as well, the speed index is the same because the speed index wants to see incrementally more content, and we're only getting the full page after 3 seconds here. However, the total blocking time is good because there's no JS for these components. And we have a 0 cumulative layout shift, which is also good. And that's because the entire screen is painted at once. So the overall score is not terrible, but the UX is terrible. And the multiple of the core web vitals are bad here. So let's also review the code. So the most important component here is a layout component. It's a root layout. And it's an async server component that can asynchronously fetch data directly inside the component. It can get the project, and it's just querying the database. And I've made it dynamic with unstable no store. But in the future, with the dynamic I/O, I'm not going to need to do this. And I've slowed it down. And the same goes for the task summary. It's a little bit slower, but it's also just getting data from the database directly. And I have here the project information. I have some status tabs here. I have a search and the children, which is this table here. Let me just get some data again. And this is inside this dynamic tab route. So this component is also a server component, and it's using the current tab and the query directly to get data inside the server component from the database. So this is our starting point here. And all of this is dynamic data, and if it were static, it would be easy because we could just run it in the build, but we need to await this at request time. So let's begin by improving the UX of these tabs, because it's taking quite a while for me to navigate to this new tab. And that's because I'm waiting for the server component in this destination route to complete rendering on the server before I can go there. And Suspense will allow me to mark a server component as non-urgent and display a loading fallback while streaming it in. I'm going to do that by making a implicit suspense boundary here with loading TSX. And I can just make a simple component, call it loading, and just render a skeleton here. And let's see how it is now. So now I can actually go to this route right away and then stream in the server component as it's completing, which is way better. As for the initial load, I'm blocked by these data fetches in the root layout. So that's why I'm getting this slow initial load. And these are actually running sequentially, even though they don't depend on each other, and they could be running in parallel. And the first thought here might be to use a promise all, but while that would help, we would still be blocked by this initial few seconds in the layout. So instead, I'm going to push these data fetches down into the components that need them. So I can move the project here from the root layout and into the project info. And then I don't need these props anymore. Let me just cut this really quick. There we go. And let's do the same for the task summary. We're going to move it into the components that's using the data. And get rid of this. So now we're actually co-locating the UI and the data here and making these components composable. And I need to suspend them now so that I can load the initial page quickly. So I'm going to wrap them in a suspense. And I'm just going to do a simple div with a loading ... for this first. And import the suspense and do the same for the status tabs. There we go. So now I can actually see something right away when I load the page and stream in these server components as they complete on the server. And I can even try to interact with what I have here. And this requires just a little bit of JavaScript to join this to the DOM. But do you notice that I have this visual instability here? And this is cumulative layout shift. And I can actually see it in the Web Vitals here, that I have gone from 0 to 0.05. And this is a very uncomfortable user experience, and it's also a core of Web Vitals, so we have to take care of this. And to do that, we want to make suspense fallbacks that are correctly suited for the content that's going to be streaming in. So I'm going to add a project info skeleton, like that. And I want to do the same for the status tabs. And now I will actually have a correctly sized skeleton here, removing this shift of this visual instability in the page. And it's way easier to try to do something while I'm loading. And my CLS is back to 0, so we're good. And my largest contentful paint and my first contentful paint have actually also become way better with the 0.1, because I'm showing the project information header right away and not blocking this root layout. So that's already a big improvement. But now I want to mark the currently active tab. So I'm going to head over to these status tabs. And I'm going to use the params from Next.js use params. And I'm going to get the active tab from this. And I need to make this a client component now, because I need to tell the bundler to load the JS for this component to use a hook with use client. And I have a problem. So first of all, client components can't be async. And that means I can no longer fetch my data in here. And it wouldn't work anyway, because this is querying the database. So that means that I have to remove this and put it back into the root layout. But I really don't want to block this root layout, right? So instead of awaiting it here, I'm going to leave it as a promise and pass it down to the status tabs as a promise. Like that. There we go. And then I can add these to the props here. Yep, and then add it to the component. And to read this promise, I'm going to get the task summary with the React 19 API use. And this will allow me to read this promise and then suspend the component while it's resolving. So we're back to the same nice pattern that we had before. So that's the point of use here. And I can actually see my active tab here. The next thing I want to do is fix the UX of the search, because it's doing a full page reload here, because it's just the default form component. Hold on, I'm going to show that to you. So the search is the default form component, and it's just using get request to push the values of the inputs inside the form to the URL. So this is like web standard stuff, right? But I want to add a progressive enhancement to this and make it use client-side navigation so I don't get this full page reload. And for that, I'm going to use the new next 15 form component. And it needs me to add an action here, and I'm just going to use an empty string so that I stay on the current route. And now I will actually not have a full page reload anymore. But it's still slow because I'm waiting for the server component to finish on the server before I can see anything. But that's at least better. And I'm going to add another progressive enhancement here with an onChange handler. And I'm going to use this change event to create some new search params. And this is going to use the existing search params and set the query for those. And then push those to the router. Excuse me. And the reason I'm using the existing search params is because I want to use my URL as state for this application, so that it can be reloaded, bookmarked, or shared without losing the same application state. So that means I'm going to need the search params from use search params. And I'm going to need the router from use router. Next navigation. That's the wrong one. You're going to have weird errors if you use that one. And again, I need to make this a client component, but that's all good. And I also want to use the active tab here, actually, to reset the form when the tab changes. So let me just import this stuff and use a key on this form to reset it whenever the tab changes. There we go. And I also need to set the default value of this input so that we will see what we've been searching for. There we go. So now, when I try this, I will actually have this onChange run after typing. And that's nice, but as a user, I really need to see that something is happening. So we're going to use a transition from React 18 to mark this state update as non-urgent and also get the pending state of that transition. So we get the pending state here, and we get a function to start this transition. And I'm going to wrap my push to the router with this start transition, marking it as a transition. And then I will use the pending state to enable a spinner down here. And let's see if that worked. So if I search for API here, I have a nice spinner indicating that I am transitioning to this new route. So that's pretty nice. And by making it this way based on the default form component, when this form is hydrated by JavaScript, it will have this enhancement behavior, and then otherwise it will just be the default form. Now I actually want to add in another component to this application. So I'm going to add in a category filter. And this component takes in a promise, reading it with use the same way the status tabs do. So I can get this up here in the layout and just get the categories with get categories map and pass it down just as a promise. And then I need to suspend again because I'm resolving this promise inside it. And I have a nice category filter skeleton here as well. Hopefully. There we go. So now I have this new component here, which has its own loading state, and it can filter categories. And let me review this. So it's also using the state as the URL as our state, as our single source of truth. And it's using the search params to toggle the categories. And when I click a category here, it takes quite a long time for me to see that I clicked it, because again, it will not show that it's active until the router has navigated to this route. And that's something I should definitely be working on. So we're going to start by indicating the loading state. And we're going to need another transition. And do the same thing as we did before. We will mark the push to the router as a transition. And we need to use the pending state somehow. But it's not really suitable for me to add some kind of spinner here. So instead, what I'm going to do is I'm going to add a data pending attribute to this div if the transition is pending. And in my layout, I actually have a class of group here, which is on this div that's wrapping everything, including the children, which is the tab page. And in here, I'm using the has pseudo class to do a pulsing animation if the group has a data pending attribute. And the way this looks is that when I'm waiting for this transition to complete, I will see that my content is stale, which is really nice. But I still want responsive clicks. So I'm going to go back to the filter here and use the React 19 hook, use optimistic. And it will take in a state to show when nothing is pending, which will be our truth from the URL of the search params here. And then it can return to us optimistic categories and a function to set them. And I can actually use this as my selected values. And then I can set this optimistically inside the transition before pushing to the router. So there we go. And what will happen now is that use optimistic will create a temporary client state, which is optimistic, that it will then throw away as the URL settles to this correct state. So now my filters don't depend on the network, and I have this instant feedback here. I need to go back to the layout, though. Oh, by the way, this pattern that I just demonstrated is credit goes to Sam Selikoff because he had made a blog post on Build UI. I did not invent this. He's the creator of that. It's really nice. But I'm going to go back to the layout because I'm calling the get categories map here. And I'm also calling it inside the task summary. So I'm calling it twice for the same page load. And I can check in the console when I load the page that it's being called twice here. Once for the task list and once for the categories filter. And I would like to reuse the return value of this function. So I'm going to head over to this function, and then I'm going to wrap it in the new React 19 cache function. And I'm going to import that. And pay attention to this page load time. It's at 2.6. And then after adding this cache, it's actually been reduced to 2.1 because I'm reusing the return value. And it's also only being called once here now. So this means that we can reuse our existing pattern of calling data directly inside components and maintain composition. I'm going to do one more optimization here, also related to caching. And because when I click these tabs, I'm always rerunning the server component. And I don't need my data to be that fresh. So I'm going to head over to the next config. Oops, not this one. And I'm going to enable stale times. And it's worth noting that in the future with the dynamic I/O and use cache and all of that, this will change. But right now, it's the recommended way to do it. So I will cache dynamic page segments for 30 seconds. And let's see if I can get this working. It's spinning. Okay, we're back. So now when I click here and then click to a different tab and then go back, it's been cached on the client here, which is really nice. So let me do like a final sort of demo of this. So I can load the page, I can stream in server components and read the content that's already there. I can start interacting with the tabs pretty quickly while this is still streaming in at the bottom here. You can zoom out here. And I can even do filtering while streaming in server components. And I can do a search and get a spinner. And I can get this pending state that telling me that my content is still. And I can reload the page and have the exact same state. So this is a greatly improved user experience. And even though the data fetches are still extremely slow, the app feels really fast and responsive. And it's also very robust because all I've been doing is progressively enhancing this no JavaScript base case and then added JavaScript to the components that I do need interactivity for. And by the way, there are no use effects or use states inside here. We're making interactive apps without it in this new world of React Server components. I can actually do one more thing here to make this even faster. So my project information is actually something that very rarely changes, and I can actually make it static. Because static is way faster, I don't need to make this dynamic and rerun on every page load. And I want to use partial pre-rendering for that. And partial pre-rendering, the way it's right now, will allow me to statically render everything that's not inside suspense boundaries. So I can remove the suspense boundary, and I can remove the unstable no store from this database query. And then I have to wrap a suspense boundary around my search params because search params opt into dynamic rendering. But that's all good. So I'm just going to add this search skeleton here. And to see the result of this, I have to make a production build. So I've actually already deployed this application on Vercel here. And what you will see is that it has an instant load of this whole piece of the layout. Show it again. When I load this page, it's just, wow, didn't work right there. Let me try again. Instantly showing this project information because it is statically rendered. So this can be very impactful on an app that has a slower or larger chunk of static content. And let me also check out the Lighthouse score. So woohoo, it's 100. And we see that the first contentful paint is on 0.2. Same with the large contentful paint because they are both this project information. And the speed index is 0.5 because we're seeing incrementally more content in the film strip here. And I still have a total blocking time of 0 because we have minimal JS and responsive clicks. Yep. And the cumulative layout shift is still 0 because I sized my suspense boundaries correctly. So this means that we managed to complete the task of improving the bad metrics and maintain the good ones. I guess I forgot to say that in the beginning, but that was what I was supposed to do for this demo. And the app is now fast, interactive, and user-friendly. Yes. OK, we can go back to slides now. Thank you. So let's get back to the slides and then summarize the best practice development patterns we covered in this demo. So the first is to resolve promises in components deeper in the tree while displaying loading fallbacks with suspense. So in this way, you will be able to unblock the page and improve performance metrics like first contentful paint and speed index, and increase the user experience. Plus, it's good for composition because every component is now responsible for its own data. But you have to be mindful and remember to size your suspense boundary fallbacks correctly to avoid cumulative layout shift. The second one is to display pending indicators using, for example, transitions to give the user immediate feedback to interactions. And the third is to put application state in the URL as a single source of truth and allow the app to be reloaded or bookmarked or shared effectively without losing its desired state. And the last best practice is to use progressive enhancement to ensure the app is functional even before JavaScript has loaded or hydrated the page. And then you can add JavaScript to the components that needed to improve the user experience while maintaining a low total blocking time. And let's also summarize what you can do with the new tools provided by React and Next.js. So you can utilize React 19 features. The cache API can perform per render caching for expensive function calls like database queries, which lets you continue this pattern of fetching data directly inside components. Then you can use useOptimistic to respond instantly to user interactions independently of the network, for example, when the following request is slow. And then finally, you can use the use API to suspend client components as they resolve a promise they are passed down. And you can also enable the relevant Next.js features. For example, you can use client-side caching with stale times to avoid needless server component re-renders by reusing these dynamic page segments across subsequent requests. And you can use partial pre-rendering to statically render pieces of the application to get a better largest contentful paint or first contentful paint and potentially largest contentful paint. So with that, this is the repo that I was working on if you want to use that as a reference. And that's it for me. Thank you, Next.js Conf, for having me here.